Hey guys, hello everyone and welcome to the channel. So this particular video is going to be about physical chemistry questions and their solution in detail for the geochemistry exam. Now I've already solved organic chemistry questions and inorganic chemistry questions. The video are already there on the channel. So do check them out as well. I'll pin them in the I button. You can click over there and watch that playlist. I also discussed about how to prepare for the general aptitude part. Okay, so do check out that playlist if you are preparing for this exam. Now talking about this particular video, it was highly requested video. A lot of you requested me to solve the questions from physical chemistry portions. I was little busy and I got delayed in this, but fine, I was busy with my lab work, so that's why it happened. But fine, now I have time for this, and now without wasting any time, let's continue with this video. Alright, so I'll take this first question over here. This was question number 41, and the question says that at what temperature does the total kinetic energy of 3 mole of helium equals to the total kinetic energy of 0.44 mole of argon gas. So the formula for this is 3 by 2. The formula to calculate the kinetic energy is 3 by 2 nRT or nKT. You can take any one of them. So using this formula, you can do it like this: 3 by 2 n1 RT is equals to 3 by 2 n2 RT. Okay, and that's what it is, n1 RT1 and n1 RT2 also, because you have to calculate the temperature. Rest of the things will get cancelled out. N1 T1 will be equal to n2 T2. Put the values of the number of moles, so that is 3 into T1, and that is equals to, because that's 3, that's 0.3 actually, so 0.3 moles of helium equal to 0.4 moles of, and the temperature is given to you as 400. Solve this up and you will get T1 is equals to 533.3. So the correct option is option number A. Alright, let's go for the next one then. Okay, fine. So the next question over here says that the ratio of Boyle's temperature TB and the critical temperature TC of the gas obeying a van der Waals equation is given by. Now they are asking about this, and you all know the formula for this, I guess. So Boyle's temperature TB is given by A upon RB, and critical temperature TC is given by 8 upon 27 A upon RB. Okay. Now if you divide this TB upon TC, so this particular part will get reversed and answer will get 27 upon 8. Okay, so answer will be option number A. You just have to divide both of them, but make sure that you are dividing TB divided by TC, not TC divided by TB. Okay, if you do the reverse, you will get option number D. That's not the correct one. The next question says that the weight of oxygen necessary to fill up a cylinder of 0.082 liter capacity at 0 degrees Celsius and 96 atm pressure would be. The compressibility factor is already given to you, gas constant is also given to you. Now the formula which we are going to use is PV is equals to ZnRT, where Z is going to be your compressibility factor. Now you know all the things like PV is equals to Z. N is number of moles that can be written as given weight upon molecular mass. So I have just written W upon M, and then you have RT. This W is what we have to calculate. That's the weight. That is going to be PVM upon ZRT. Put the values. Pressure is given to you already. That is 96 atm. Volume is 0.082, and mass, molecular mass of O2 is going to be 32, right? That's what it will be. Z is going to be 0.96, R is 0.082, and temperature is 0 degrees Celsius, that means 273 Kelvin. Do it of your own, use your calculator and verify the answer. The answer will be option number A, 11.72. Okay, I have already done it, but it's a good practice that you should verify it. Then it will be like that question will remain in your memory for a longer time. All right, let's go for the next one. It says which one of the following following gas. The next one says which one of the following gas samples will have the highest average molecular speed. Now the formula for calculating average molecular speed is VRMS, and that is equals to under root 3 RT upon M. So if your M decreases, that is mass decreases or molecular mass decreases, your VRMS is going to increase. Now you can look upon it oxygen, neon, carbon and helium all are having their own molecular masses which are already given. The least one is helium, so its VRMS will be highest. So the answer is going to be option number D, because that is going to have the least molecular mass. The next question says that the root mean square velocity of monoatomic gas of molecular mass m and is u. What is the correct relation between u and the average kinetic energy? This is very simple question, and I will just give you the formula. The formula for calculating kinetic energy, which is denoted by u over here, the kinetic energy is denoted by E over here, is equals to 3 by 2 RT, and the root mean square velocity, that is VRMS, that is denoted by U here, that is equals to under root 3 RT upon M. Just look upon the both the equations. Now you can do what? You can just substitute at the place of this as U is equals to under root, in the place of 3 RT I can put 2E, right? So it will be 2E upon M, and that becomes your option number C. So this is how it has to be done. Let's go for the next one. It says that the amount of energy per molecule of the monoatomic gas that will increase and increasing at temperature by 1 degree at constant volume. Now you know that this is a formula, or this is a definition of CV, and for monoatomic gas, CV is equals to 3 by 2 R. That becomes your option number C as the correct option. All right, let's go for the next one. Then the next question says which among the following gases has the largest mean free path under the same external condition? So I'll just give you some point. You can note it down, that is smaller the molar mass or smaller the molecular mass, that means high mean free path. Okay, mean free path. Basically, what is mean free path? Mean free path is the average distance or average length which is traveled by the moving particle, by the gaseous molecule, between two successive collisions. So between doing two collisions, how much distance a particular ion has moved, or a particular molecule or particular particle has moved, that gives its mean free path. Now, if smaller the molecular mass, it will be less chances of collision will be, and that's why higher its mean free path will be. So among the following, if you look upon the smallest, having like smallest one is hydrogen, and that's why that's going to be the answer. All right, let's talk about this question here. It says 50 ml of H2 gas diffuses through a small hole from a vessel in 20 minutes. Time taken by 40 ml of the O2 gas to diffuse under the similar condition will be. For this, we will use Graham's law of diffusion, and that gives you R1 upon R2 is equals to under root M1 upon M2. M2 upon M1. Okay, so that has to be M2 upon M1, where M1, M2 are masses and R1, R2 are rate of diffusion. So basically, any rate of diffusion is given by V upon T, that is volume which is being diffused divided by the time taken. So if I put all the values, so R1 is going to be like V1 upon T1, and R2 will get reversed, and that is going to become like T2 upon V2, right? Because 1 upon R2 is written, and this is going to be under root M2 is the mass of oxygen. That's okay, fine, let's keep it M2 upon M1. Now we are going to put the values. So V1 is going to be the volume of H2 gas, that is 50, and T1 is going to be the time taken, that is 20, multiplied by T2 is what I have to calculate, divided by divided by V2 is the volume of it, so that is 40, and this is going to be under root of 32, that is the mass of O2, and divided by the mass of oxygen. Solve this out and you will get option number B as correct. Okay, so you have to do the calculative part. Do that and check it and verify. I have done, but you have to verify that. Let's go to the next one. It says what will be the slope of the plot of log P versus log V for the reversible adiabatic expansion of the ideal gas. Now we know for this PV to the power gamma is equals to constant. Let's keep it as K. Take log, so it will be log P plus it will be log V to the power gamma is equals to log K, or you can write down log P is equals to log P plus gamma log V is equals to log K, or basically what you can do, you can take it to the other side, it will become log P is equals to minus gamma log V and plus log K. Now since you are plotting the graph between log P versus log V. So the slope is going to be minus gamma. Option number B is the correct option. Let's go to the next one then. It says that the latent heat of vaporization of Br2 at 59 degrees Celsius at 1 atm pressure is 29.2 kilojoules per mole. The value of delta U would be. So this is pretty simple question. Latent heat of vaporization is given to you. That is your delta H, and that is given to you as 29.2 kilojoules per mole. You have to calculate delta U. You know the relationship between all these things, like relationship between U and a relationship between your H. So you know that delta H is equals to delta U plus P delta V, or you can say that delta U is equals to delta H minus P delta V. Or you can put P delta V in the place of P delta V. You can put, because you don't know the value of P delta V over here, so you can just put it as nRT, because the number of moles is not given. You have to take number of moles as 1, so you can take it as RT, and then you can solve this to get the answer. So your delta U is going to be delta H minus your R and T. So let's do it. So that is going to be your like R and T. Just put the values now. Okay, delta H is already given to you as 29.2 minus the R value is going to be in kilojoules. Okay, I have kept everything in kilojoules, so you can keep it in kilojoules because R is also given to you in kilojoules itself. So 8.314 into 10 to the power minus 3 multiplied by the temperature, that is 59. Convert this into absolute, do it and solve, and you are going to get option number A as the correct one. Try this out and do it of your own and check out whether you are getting or not. Okay. The next question says that the ratio of specific heat of gases at constant pressure and constant volume for N2 molecule is. Now N2 is a diatomic molecule. For that your value of Cp is going to be 7 upon 2 R, whereas the value of Cv is going to be 5 upon 2 R. Now the value of Cp upon Cv is going to be 7 upon 5. Divide that and your answer will be 1.4. So option number B is the correct option. Going for the next question, it says that the total heat content of the system at constant pressure is known as, we all know the definition of enthalpy, that is equals to the total heat content of the system at constant pressure, right? Let's go to the next one then. The next question is from your Joule-Thomson coefficient, and it says that the Joule-Thomson expansion of real gas at inversion temperature, what it does, it becomes 0, because at the inversion temperature, inversion temperature is the temperature where the Joule-Thomson coefficient becomes 0, right? So by the definition it's correct. Okay, the next one, it says for N2 and 3H2 gives you 2 moles of NH3. The expression for delta H is, now we know delta H is equals to delta U plus P delta V. Now since P delta V is not given to you, so we will write down delta U plus delta nRT. Put the value of delta N over here. Delta N is going to be minus 2. Why? Because this is 1 mole, this is 3 mole, and you are getting 2 moles. So delta N will be number of moles of product, that is 2, minus sum of number of moles of reactant, that is 3 plus 1. So 2 minus 4 is going to give you minus 2. So put minus 2 here and you will get delta U minus 2 RT. Option number C is the correct option. Going for the next question, it says that the entropy of vaporization of liquid is 100 joules per mole per Kelvin. It boils at 300 Kelvin. What would be the value of delta H vaporization? So delta H of vaporization will be equal to T delta S. Put the value over here and you will get the answer. So 300, and the change in entropy is 100 joules. So put it and you will get answer at 31234 zeros, or you can say 30 kilojoules, okay, per mole. So answer is option number B. Going for the next question, it says maximum efficiency of the Carnot engine between 100 degrees Celsius and 200 degrees Celsius. Convert the temperatures into absolute temperature. First of all, 100 means 373 Kelvin and temperature 200 means 473 Kelvin. Now do this thing. So eta is equals to T2 minus T1 divided by T2. Put the values over here, and it's 473 minus 373 divided by 473. Solve this up, and since you have to convert it in percentage, so you can multiply with 100% and your answer will be option number B. So your option number B is the correct one. Okay, the next one says which one of the following is the correct thermodynamic equation of a state? Option number D is the correct one. This is second thermodynamic equation of state. All right. Okay. The next one says which one of the following changes will necessarily lead to the non-spontaneous change. So answer will be option number C, which says positive delta H and negative delta S. You know that delta S, if it is negative, that's non-spontaneous. Delta H positive means that reaction is actually a endothermic reaction. Endothermic reactions are non-spontaneous. Exothermic reactions are spontaneous. All right, let's go for the next one then. The next question says that equal volume of what concentration of AgNO3 and HCl should be mixed to form AgCl. Now the KSP is given to you for this particular thing. So we know that if something has concentration greater than solubility product, it will get dissolved. Okay, so if KSP is 10 to the power minus 10, so if I mix both of them and the total concentration is more than 10 to the power minus 10, then it will dissolve. For example, 10 to the power minus 4, 10 to the power minus 7 will make it 10 to the power minus 11. That will dissolve. Same goes for option number 2, same goes for option number C also. In option number D, you can see it will become 10 to the power minus 4 and 10 to the power minus 5. Overall, it will become 10 to the power minus 9, and that's where it is less than KSP. Okay, so 10 to the power minus 9 is less than your KSP value, and that's why this is the one where the precipitation is going to happen. Okay, so precipitation will happen in option number D. Okay, the next question says that the solubility product of Ag2CrO4 is given to you. What is the concentration of CrO4 2 minus? This was a very good question. The question will be done in this way. You have Ag2CrO4. It is going to break into 2 moles of silver ions plus a CrO4 2 minus ion. Now what you have to do is you have to find out KSP. KSP will be product of the concentrations of both of them. So Ag plus square and a CrO4 2 minus ion. All right, now in the equilibrium this silver is getting 2 times formed, so that's why if X is the solubility, this will be 2X, right, and square of that, and this is going to become X. You know that, right? If this is, let's say, this X moles of this is getting soluble, so this will be 2X moles formed and this will be just X mole formed. So that's what I have put over here. So this will become 4X square and X, so this will become 4X cube. That is your KSP. Now KSP is given to you as 32 into something, so let me do it. So 32 into 10 to the power minus 12. This side you have 4 into X cube divided by 4, it will be 8 into 10 to the power minus 12, and that's your X cube. So X will be cube root of 8 into 10 to the power minus 12, and X is going to be 2 into 10 to the power minus 4, and that's your option number A. So this is how option A is your correct option. Looking forward for the next one, which says what will be the degree of dissociation of 0.1 molar barium nitrate solution if the want of factor of the solution is given to you. So first of all, to do this question, you should know this, that barium nitrate, BaNO3 whole twice, is going to break into barium 2 plus and plus NO3 minus 2 moles of this, right? So that means if I try to find out that what is the total number of moles which it is going to get dissociated into, so number of moles is 3, right? 2 plus 1, 3. Now degree of dissociation is given by I minus 1 upon N minus 1, where N is the number of mole, I is the want Hoff factor, alpha is the degree of dissociation. Just put everything, and that's what it is, 2.74 minus 1 divided by 3 minus 1. Solve this and it will be 1.74 divided by 2, and that is going to give you around 87 or 0.87. So 87% will be your answer. That is option number B. Alright, let's go to the next one, which says which one of the following colligative property can provide the most precise molecular mass of the peptides, and that's your osmotic pressure, because osmotic pressure directly it is related to concentration, and which is directly related to the number of moles, and once you get the number of moles you can easily calculate the molecular mass, right? So option number D is the correct one. Okay, going for question number 63, this was pretty simple. It says the total vapor pressure in torr for the mixture of volatile component A and B is given to you by this equation, that is P minus 120, P is equals to 120 minus 75 XB, where XB is the mole fraction of B. Now they are asking what is the vapor pressure of pure A and B. So for pure A, what it is going to happen, that XB will be 0, right? There will be no amount of B over there. So if you put 0, your for pure A, your total pressure will be 120 torr. And if I ask you for pure B, in that case your XB will be equal to 1. So total pressure will be 120 minus 75. That will be around 45. So correct answer is option number C. Alright. So this is how it has to be done. Let's go to the next one. Okay. The next question says which one of the following equations represent the correct relationship between relative lowering in vapor pressure and the osmotic pressure. This is a direct question, direct equation it is for the dilute solution. This one will be the correct one. The next question says that 1% aqueous solution mass by volume of certain substance is isotonic with 3% solution of glucose at the given temperature. The molecular mass of the substance will be. So isotonic means the osmotic pressure is same. Okay, osmotic pressure is same for them. Alright, now we can do this. So that means if I have pi 1 as the osmotic pressure of other two of them, pi 1 and pi 2, so pi 1 will be equal to pi 2. Pi is equals to CRT, so that will be C1 RT is equals to C2 RT. You can cancel out R and T, so it will become C1 is equals to C2. So these are the concentration. Now concentration, if you want to express in terms of like your mass by volume, so you can just mention it as mass by your, or yeah, so that's, or basically you can write it down like this. Concentration is number of moles divided by volume, so it will be N1 upon V1 and this is going to be N2 upon V2, right? Now number of moles is given weight upon molecular mass, so let's do that. So given weight, so W1 upon molecular mass is M1, V1 was already there, N2 will be like W2 upon M2 into V2. Now what is given to you is your percentage aqueous or mass by volume. That means W upon V is given to you. So W1 upon V1 is given to you as 1%, that is 1 upon 100. So W1 upon V1 is 1 upon 100. In the same way, W2 upon V2 will be 3 upon 100. Okay, that's because 3% is given. So let's put that. So 1 upon M1, M1 is the mass which I don't know, that is of the certain substance, divided by 100, that is 3 upon M2 is glucose, so that's value is already given to you. So 180 into the volume is 100. So solve this up and you will get your M1 as 60 grams. Now that was not matching with the option. So what's wrong here? The wrong thing is that the answer was asked in kilograms. Okay, so convert these grams into kilograms and your answer will be option number D, that is 0.06 kilograms per mole. Okay, that this answer will be grams in grams per mole. All right, I think this is much clear. Let's go to the next one. It says which of the following is the correct order of osmotic pressure of equimolar solution of glucose, sodium chloride and barium chloride. Now osmotic pressure is a colligative property and you know that the colligative properties depends upon the number, okay, number of ions or number of systems basically. So if you look upon this, barium chloride is going to break into barium 2 plus and 2 moles of chlorine, and so total in how many number it is going to dissociate? So that is 3. In 3 things it is going to dissociate. If I talk about NaCl, so that is going to dissociate in Na plus and Cl minus. So in 2 things it is going to dissociate. Talking about glucose, C6H12O6, this is not going to dissociate at all. So C6H12O6 will remain as it is. So 1. So the correct order is going to be option number C, depending upon in how many species it is going to dissociate. Okay, next one is again a numerical. It says 0.05 molar aqueous solution of K4 FeCN6 freezes at this much degree Celsius. Its degree of dissociation is going to be how much? So we will do this with this. The formula is given by this, right? It says that TF is or delta TF is equals to KF and M, right? That's what I have. M is molality, and since we have to also include the Van 't Hoff factor over here. So this is the formula, delta TF. So Since it's an aqueous solution, so the usual degree Celsius is 0 minus, the new one is minus to 0.26, so this is going to be 0.26, and that is going to be equal to I. Kf value is given to you as 1.86. Since it is in degree Celsius, that's why I have not converted temperature into Kelvin, okay, and multiplied by molality, that is 0.05. Solve this up and you will get I is equals to 2.80. That's your want of factor. Again, now same formula which we have earlier applied, so alpha is equals to I minus 1 divided by n minus 1. Now here the form, if you look upon the formula, so the value of n is going to be 5. Why? Because K4FeCN6 is going to dissociate into 4 moles of K plus ion and FeCN6 minus ion, okay, or 4 minus ion. So there are total 5 ions which is going to dissociate. So value of n is going to be 5. Put everything here, so that is 2.80 minus 1 divided by 5 minus 1. Solve this and you will get alpha as 0.449, and in the percentage that is going to be 44.9%. Okay, so this is how it has to be done. See, the questions which are here are not that difficult. They all are from your 11th or 12th class level questions, IIT JEE level I would say. But the only thing is, if you remember this formula, when we prepare for CSIR net or GATE, we don't memorize these formulas or we don't do questions related to this, although this time GATE was most of this like colligative properties and all, but fine, you should know these formula, then only you'll be able to do these questions. Okay, the next question says that the value of freezing point depression constant for cyclobutane having freezing point of 280 Kelvin and the molar enthalpy of fusion is given to you. So how it will be done? The formula which we are going to use is this, that is Kf is equals to m1 RT square divided by 1000 into delta HF. Now the things which are given to you is m1, that is the molecular mass, R is given to you, temperature is given to you as 280, 1000 will remain as it is, delta HF is enthalpy of fusion, and that is going to give you the value of Kf. Put everything and solve. Okay, I have done on my calculator and that's why I know it. So the answer will be option number C. Okay, so this is how it will be done. The next one says which one of the following statement is correct about the Henry's law? Simple and straightforward. It is related to the effect of pressure only on solubility of the gas in the liquid. Simple statement based question. Okay, the next question is again a good one. It says what will be the ratio of mole fraction of O2 and N2 dissolved in water at 25 degrees Celsius. Henry's constant is given to you for O2 and N2 and you have to find out, yeah, fine. So you have to find out what will be the ratio of mole fractions, okay. All right, so how it will be done? See, this thing now, mole fraction of O2 and N2, it should have been mentioned like partial pressures, or you can understand that the mole fraction only like it is going to affect the partial pressure. So if the ratio of mole fraction is 0.2 and 0.8, so their ratio is going to be 1:4, right? The ratio is going to be 1:4, and the same ratio is going to be for the partial pressure of O2 and N2 both. Okay, why I'm telling so? Because the formula needs that. Now the things which are given to you is Henry constant of O2, that is 3.3 into 10 to the power 7, and Henry constant of N2, that is 6.5 into 10 to the power 7. So these two things are given, and mole fraction of any species X is given by P upon KH. Okay, pressure divided by the Henry's constant, or you can write it down as partial pressure, basically, not pressure. Fine, so just put these things. So if I have to write down the mole fraction of O2 divided by mole fraction of N2, this is going to be equal to the partial pressure of O2 divided by the Henry's constant of KH of O2 multiplied by, this thing will get reversed, so Henry's constant of N2 divided by partial pressure of N2. Put all the values which I have already given to you. Now what you are going to put for PO2 divided by PN2? Put 1 upon 4, because I told you, right, that the ratio of mole fraction is going to be the ratio of your partial pressure. So PO2 upon PN2, for in the place of that you can put 1 by 4 and solve this. So you are going to get N2 is 6.5 into 10 to the power 7 divided by this is going to be 3.3 into 10 to the power 7 multiplied by For this I am just putting 1 by 4. Solve this whole thing and you will get 1 upon 4 as the answer, or 0.25 approximately. So that's your answer. Okay, option number C. You can try this of your own as well. Okay, the next question now is from electrochemistry. You know this easily, like this is from your CSI net also. Cell constant of 0.1 normal KCl solution is found to be this much. Resistance offered by 0.01 normal of your HCl is 89 ohm. The specific conductance of HCl is going to be. So this question will be done like this. A specific conductance, okay, specific conductance, specific conductance is equals to your specific conductance is equals to conductance basically into cell constant. Okay, cell constant. Now the cell constant for 0.1 normal KCl solution is given to you, and they are asking you for a 0.01 normal KCl solution. All right, that's what the whole question is all about. So specific conductance is going to be equal to, conductance will be 1 upon resistance. So you can also write down it as cell constant divided by resistance. Now one thing I want to make very clear, that the cell constant over here does not depend or does not changes by changing the concentration, because the cell constant depends upon the electrolyte which are used, the distance between the electrolyte and the cross sectional area. So it is not going to change with the concentration. That's what it is, and that's where they try to confuse you. They have given you KCl and HCl, two different things in the solution, and they have also changed the concentration, but the cell constant is not going to change. Okay, so the cell constant will remain same. So just put it as it is. So it is going to be 0.98 and divided by the resistance is going to be 89. Solve this up and you will get your option number B as the correct one. All right, so this thing you have to be careful. The next question says, which of the following is the correct order of mobility of the following alkali metals? Now to do this you have to remember one thing, that is smaller the size of hydrated ion. Okay, hydrated ion, more is the mobility. So taking that into consideration, the smallest size of the hydrated ion is for rubidium, because you know, as the size of the ion increases, the size of the hydrated ion decreases, right? Hydration energy decreases over there. So yeah, that's why your option number D is the correct option. Let's go for the next one. The next question says that during electrolysis, a silver nitrate solution, loss of anode compartment was 0.589 grams. In a voltmeter connected in series, 1.259 grams of silver was deposited. What would be the transport number of the two ions? Now this question, I feel that there is few data which is missing. I am not quite sure about this. So this question is still not solved, and I think there is very simple equation which is going to be used, but I am not aware about that. If any one of you knows this or how to solve this question, you can just give a hint in the comment section below, or give the equation in the comment section below, so that those who are watching, they will be able to solve this. Okay, I'll pin the comment if your solution or if your equation will be correct. All right, but I have just taken the standard formula or the standard value of your transport number when this much amount of silver get deposited, and for that I got that option number A will be the answer. Okay, so the answer is known, that is going to be option number A, but the equation is not known. So if you know, do let me know in the comment sections. All right, the next one says that the molar conductivity of KOAC, that means like potassium acetate, and KCl at infinite dilution of water at 25 degrees Celsius is given to you respectively. To calculate the molar conductivity of HOAC at infinite dilution, the additional molecular conductivity value of which of the following electrolyte will be used? So it's simple. By the Kohlrausch law at infinite dilution, you have studied that. If you know for KOAC, if you know for HCl, to calculate for HOAC, you need for KCl, right? So KCl should be known in order to do that. So simple and direct answer for this. Question number 75 says, which of the following is the effect of dilution on a specific, okay, what will be the effect of dilution on a specific and equivalent conductance of the aqueous solution of a strong electrolyte? The answer is A, the specific conductance decreases. equivalent conductance increases. You should know this. These are all from your Kohlrausch laws. Okay, the next one says that the mean ionic activity coefficient is denoted by gamma plus minus, while that of the cation and anion are denoted by gamma plus and gamma minus respectively. The correct relationship between them, simple and direct question from your ionic strength, and that's your option number B. Alright. Okay, the last few questions are over here. It says that the specific conductance of 0.01 molar solution of acetic acid was found to be this much. At 25 degrees Celsius, the molar conductance of acetic acid at infinite dilution is given to be this much. So this is lambda m, this is lambda naught m. So the degree of dissociation, that is alpha, is equals to lambda m upon lambda naught m. Put these values and you will get option number A. Simple and straightforward, okay, just by putting in the formula. Okay, the next one says that the moving boundary experiment with 0.01 mole, this should be mole, lithium chloride, the boundary in a tube with cross section area this much moves through 8.1 centimeter in 1500 seconds for the current of this much ampere. What will be the value of transport number? Now here the formula for transport number will be used. Transport number of any cation or anion is actually given by, if they are asking for chlorine, so let's write down for chlorine. This is going to be the length multiplied by area of cross section multiplied by the concentration divided by 1000 multiplied by the Q. Q means the Q is going to be the charge per second which we are experiencing multiplied by the Faraday constant. So by doing all this, you will get the transport number. For calculating Q, which is not given directly, Q will be done by I into T. I is the current value, time is also given. So multiply both of them to get Q. Once you get Q, all the things are given. See, this is the concentration, this is the area, this is the length. So L, A and C are already given to you. Q you can calculate, put it, multiply with Faraday 96500. Temperature is not needed and it's not required to solve. The transport number which you will get is going to be 0.361 as the answer. Okay, so do these calculations of your own. I'm just giving you formula. I have solved these things and I have verified. Okay, I'm not putting and multiplying and showing you. It will just take your time, right? So just do it of your own. The next question says that the HCl is titrated against NaCl, the conductance at the end point. You know that the conductance or the conductometric curve for a strong acid and plus a strong base, the graph goes like this with one end point. So the conductance at the end point is going to be minimum. Okay, so the conductance remains minimum at the end point, you know that. Okay, the next question says that a cell is bathed at in a solution that has greater osmolarity than that of cytosol. The solution can be described as, so this answer is going to be hypertonic. Whenever something has more like osmolarity is greater than that, in that case we call it as hypertonic. If osmolarity is less, we call it as hypertonic. If it is same, we call it as isotonic. Okay, and if it is same to the water, then it is called as hydrotonic. So these are the terms. Alright, so these were all 40 questions from your physical chemistry part of your combined Geo-Scientist exam. I hope the solutions are much clear to you. If any question is there which you didn't understood, or if any question is there where you think the answer would be something different, the comment section is open to you guys. You can comment that down every time, okay, anytime, right? And that's all from my side for this particular video. Thank you so much for watching the video, and I'll see you in the next one. Till then, have a great day. Bye bye.